Good morning, good evening, ladies and gentlemen, and we're going to be discussing lab number two. Um, lab number two is our experiment on separating the components of phenacetin. And in this experiment, what we're going to be doing is taking the drug phenacetin, which is about, and I'm still not sure on this, if it's 40 or 10% sugar, 40 or 10% aspirin, and 50% the one of the two illegal drugs, acetanilin or phenacetin. Our drug's gonna be called panacetin, which was supposed to be, this um, miracle compound that's illegal in the U.S. now. Acetanilin and phenacetin were used for years as painkillers. Found out acetanilin causes severe anemia in people. And phenacetin, long-term use, kidney damage, cancer in some people, and anemia. So what we're going to do is use your job is to determine the percentage of the three. You have the given percentages. We're going to see how close you come to the answers. I will tell you, it doesn't. This lab typically doesn't work real well on the first portion of the experiment. So we're going to see some skewed data when we do this. You have to do it quickly and you have to do it correctly on the first step. Unfortunately, apparently I gave away all my copies of the flowcharts to you guys, so I need one back from someone on Thursday, or anybody could upload one to, or email me one. It would be perfect. But what we're going to do is we're going to use properties of solubility. Some chemicals are soluble in certain solvents, others aren't. We're going to start with the nonpolar solvent dichloromethane. And sugar is pretty much insoluble in dichloromethane. Whereas aspirin, acetanilin, phenacetin, acetaminophen, they're all soluble in dichloromethane. And it turns out that all those are fairly insoluble in water, whereas sugar is very soluble in water. So what we'll do, and I'm just going to try to recreate the flow chart, is what I'm going to do with it. So what I'd like to do is just make that. We're going to start with all of them here, and we're going to add dichloromethane, which is CH2Cl2. Now, what's going to happen to that is the sugar won't dissolve. So what we're going to do is you're going to just add the dichloromethane, swirl for quite a bit of time there, and just allow the material to dissolve. And when it has dissolved, the sugar should be undissolved. So what you're going to do is take the entire thing and put it through what's called fluted filter paper. Watch the video I will post on how to make fluted filter paper. Don't ask me to fold your filter paper. Watch the video, learn how to do it. It's not that difficult. I'll demonstrate it in class. And some lucky winner will probably get the piece that I fold. Oh, mine will probably be way too big for what we want to do. Now, here's the issue. Dichloromethane evaporates unbelievably fast. So the problem is going to be and we are going to use the fastest filter paper we have in the lab. They make different speeds of filter paper. So what you want to do is, if you can, you would like to, the goal is to try to pour as much as you can into the filter paper as you can all at once. The problem is, if that dichloromethane is evaporating, it's going to leave behind your materials. So in the paper should be, and the problem is we find out that we get some of everything in here because of the evaporation. In the paper should be the sugar. Over here, in this side, what should be true should be that in the liquid, then that should be your aspirin and I'm going to call it the unknown, because you don't know which one of the two drugs you have, phenacetin or acetanilin. And guess what lab number 3 is? We identify which one of the unknown drugs that we have. So I'm just going to call it the unknown in the rest of this experiment. Make sure you weigh this filter paper, because your sugar mass is going to be pretty much the mass of what's left in that filter paper. If you technically, you'd want to actually, and by the way, do not use vacuum funnel. This is gravity filtering. Gravity filtering on this. All right, then what we're going to do is we're going to add baking soda to this, an NaHCO3 solution, which is going to have water in it. So now what's going to happen in that respect is going to be in the dichloromethane layer, which is the bottom because it's denser than water, the unknown will be there. Over here in this layer will be the aspirin, but it will have been converted to an ionic solid, an ionic compound. So this will be the water layer. That'll be the top. So the baking soda converts the aspirin into a salt. Acid-base reaction. Aspirin's an acid. Acid plus base, you'll remember, probably a quiz question, makes a salt plus water. A salt plus water. This is not table salt. So that's not aspirin now. It will be sodium acetylsalicylate. Whereas this was acetylsalicylic acid before, it now becomes sodium acetylsalicylate. Over here, untouched, still hanging around in this dichloromethane layer. By the way, keep these covered. This dichloromethane is noxious. If it's bothering you, we don't know how the new system's going to work in the room. You may need to go to the fume hood with that portion of the program. Now, this is going to be put in a separatory funnel. Watch the video on how to use a separatory funnel. And make sure that you know which layer is which and which thing to keep. Okay? This thing's really actually done. So at this point, what you're going to want to do with it is we're going to make this better next week. We'll talk about how to do that and figure out what it is. But for the purposes of this lab, all we have to do is the easiest way to do this is to tear a beaker, add this liquid to it, and then evaporate off the dichloromethane, which can be done with air. And that's the issue. But the problem is we're going to have some sort of a trap. Look in the techniques in the back of the book on how to build a trap. Essentially, you're going to take a funnel, put it over your beaker while you're evaporating it, and hook that to the vacuum line to suck that out. So you're going to suck out so evaporate with a trap or in the fume hood. Problem is limited access in the hoods. We only have 4 sites in the hoods, so 4 groups could go to the hoods. That doesn't take care of the other 7 groups. The aspirin then. All right, now my videos, I don't know if I mentioned it at the beginning, they get cut off. It's the subscription we have here to use these, so there'll be like a second video or third video that we will use. I'm just going to wait for this thing to tell me it's starting to run out of time, so we may have to continue on. Well, now this is an aspirin. This is, there we go. So I'm going to go ahead and do that.